Okay, we're good. Mic check. All right, so we're going to start looking at Z-scores. Now, we've learned a lot of, I guess, different words associated with data that I guess we haven't really looked at before. So I do want to kind of summarize a little bit, but essentially we've got our normal distribution, which is just like a bell curve or that symmetric shape. Our mean is sitting in the middle somewhere, and just a bit of notation, mean you can think of as x, and then we say bar, literally a bar on top of it. That's our mean. And then we said, okay, we've got certain standard deviations, so 1, 2, 3, and the greatest percentage of our scores lie within 3 standard deviations. This is -1, -2, -3. And so this all took up 99.7% of the scores, and I left that in the top corner here, and that was our empirical rule. And yeah, a Z-score is essentially just, or you can, it's probably better to think of it like a standardized score, but it's sometimes called that. It's so pretend you've got a score, like let's suppose we did a test. So I guess this is the most relevant part, or the part that we would have seen it in before. Well, suppose we've done a test and the average mark was whatever the average mark is. Maybe this is 70. I'm going to write this. Maybe this is an average mark of 70. Okay, and then I look at my score. Me being me, maybe I got 89. And so let's suppose my mark of 89 is sitting here or something. And we had a certain standard deviation. I don't know what that is, but my score was approximately 1.8 standard deviations higher than the average. And so that's what my Z-score is. So what it is it's a way of comparing all of our scores. And the way we compare it is with a Z-score, and our Z-score is the number of standard deviations away we are. So let's suppose that's kind of not a nice number, but let's suppose our standard deviation is 5, maybe. Then a score of 75 would be 1 standard deviation away, which means my Z-score would be 1. So in other words, if you have a higher Z-score, so something from like 1 or 2 or 3, that means you're greater than the mean or greater than the average. If you're less, so let's suppose this person got 65, that would be a Z-score of -1. A Z-score of 60 would be -2. A Z-score of 55 would be -3. And then you'd expect that 99.7% of the scores would be between 55 and 85, like something like that. So that's where I guess, you haven't really seen Z-scores before, but you can kind of think of it as a way of comparing everybody's scores. So I guess what you should probably would be a good idea to ask is whenever you get given your test results or something like that, just ask what the average is, which is normally what people do. You ask what the average is, and then you think about how far away your score is from the average. More specifically, ask what the standard deviation is, and then see how many standard deviations away from the mean you are. So suppose you're just higher, think about how many standard deviations away that would be your Z-score. And so instead of comparing marks with people, you'd maybe compare Z-scores. Anyway, that's what Z-score is. There's a way of working out exactly what your Z-score is. So you'll notice that this person's was 1.8. This isn't accurate, so I'll rub that out. 1.8, so obviously between 1 and 2. There's a way of working that out. It's this little equation here. So it's your score minus the mean divided by the standard deviation. That gives you your Z-score. And this is just the diagram that we've had in the top corner. One thing to note is if you have, just disregard this for a sec, if your score is the mean score, then your Z-score is going to be 0. That means you're no standard deviations away from the mean because you are the mean, if that makes sense. Okay, so this is the only example we're going to do, but this is something we could have, so minus this question, right? Minus this question, kind of. We could have calculated where these are on our normal distribution. So if the mean is 600 and the standard deviation is 5, then like I don't pretend this doesn't exist. This question we were asking last lesson, or the last 2 lessons, we can kind of just draw this anyway, and that's how I would approach this question regardless. I'd always, because I'm told that it's a normal distribution, and I'm told what the mean is, and I'm told what the standard deviation is, I'll probably just draw it anyway, just to get an idea of whether my answers are going to make sense. So I'll draw my standard deviation thing. Okay, so I mean my normal distribution. So my mean here, I'm going to call that x bar, is 600. So 600. Now, 1 standard deviation away, 2 standard deviation, 3 standard deviation. So the standard deviations are 5 mil. So I add 5 mil, 605, add 5 mil, 610, add 5 mil, 615. 1, 2, 3, 595. Let's see if my addition is better today. This is subtraction. Okay, so one thing to note, 99.7% of my scores are between 585 and 615. I do call them scores, but in this we're talking about cartons of milk. So whenever I refer to as a score, it's just like one of the values that was recorded. So if I measured everyone's heights, I might have a height of something, but really I can consider it a score. Or when we talk about test marks, it's another way of saying that is a score, I guess. Anyway, so I've drawn my thing. Let's answer this. So I want the Z scores for each of these amounts. Now, this first one's really easy, 610, because you can see quite clearly that 610 is 2 standard deviations away from the mean. So I know that the Z score, so the Z, I need I know that the Z score is equal to 2, because it's, sorry, wow, 610 is 2 standard deviations away. That's easy. If you can read it off the graph, that's fine. But with something like 596, I can't, because I know what 595 is, and I can kind of estimate where it's going to be. Like this is a Z score of -1. Maybe I'll draw my Z scores up here. 0, 1, 2, 3, -1, -2, -3. So I'm expecting a value a little bit this direction of 595, because I'm looking for 596, right? So 596 is going to sit here somewhere. So I'm expecting my Z score to be between 0 and -1. So hopefully I get that. And I can use the formula to work this out, but like to verify if I wanted to. Okay, so Z score is equal to your score minus the mean divided by the standard deviation. So that's going to be my score, which is this thing, so 596. So 596, take away the mean, 600, and I'll divide by standard deviation, which is 5, and that's going to be equal to, now just think about this, this sum or subtraction up here, that's going to produce a negative value, which is what I want, because I know that my value here is a negative Z score, so that's a good thing. Now if I put this in the calculator, where's my calculator? There it is. 596 minus 600 divided by 5. I must have typed that in wrong because I got exactly -1. 596 minus 600 divided by 5. There we go. Okay. Wow, I feel really stupid because that's obviously just -4 over 5, which is what my calculator's produced. Anyway, okay, so minus 0.8. And that's kind of what I expected. So this sitting here is 596 and has a Z score of minus 0.8, and that kind of makes sense. So that just means that this carton of milk is negative 0.8 of standard deviations away from the mean. All right, let's have a go at the second one. So this is kind of backwards. What amount of milk has a Z score of that? So I'll start with my Z score. It's 1.5. 1.5. I know that it's my score minus the mean, 600, over the standard deviation, which is 5. And what I want is what amount of milk, which is the score. So that's what I'm trying to find. This X value is the score that I'm trying to find. I hate how this is down there. It's better. Okay, so essentially now I have to solve this as if it was an equation. So I'm going to multiply this 5 up. So it's 5 times 1.5 is 7.5. X minus 600. That means X equals 7.5 plus 600, which is 607.5. And just going over to our diagram. So a Z score of 1.5, that's 1.5 there, so 1.5 you'd say is around there. So you'd expect my score to be between 605 and 610. 607.5 is dead middle of that, so I'd be pretty happy that my answer makes sense. Okay. All right, a z-score of negative 2.6. So negative 2.6. It's my score minus the mean over the standard deviation. So I'll multiply the 5 up. Negative 13, what the hell? A nice number. X minus 600. Okay, and then I add 600. I got 587. So that means that, and think about this, minus 2.6 of a z-score. Minus 2.6 would sit around there, minus 2.6. That means my score needs to be between 585 and 590. 585 and 590, that seems pretty correct to me. Okay, very last question. What percentage of cartons have less than 590 milliliters of milk? So 590, that's here. So 2 standard deviations away, or a z-score of minus 2. I'm looking for this percentage here. So if you look up in the table up there, you can see that I was about to point. Let me not let go of this. So 2, where's my mouse? 2 standard deviations is this line here. So I'm looking at, not the whole thing, just highlight that please. Whatever. You get it, this part. That part. So 2.35 plus 0.15. So that percentage, that, which is question C, is at 2.5%. So a different way that a question could ask that is what percentage of cartons have a z-score less than minus 2? That's the same thing. Minus 2, less than that is this, same thing. So I just want you to get used to working with z-scores. It's nothing new. It's just a new way of saying how far away something is from the mean, or how many standard deviations away it is. It's the exact same thing. You've already been doing this. You just haven't called it a z-score. You've just called it, so for this one, you just called it 1 standard deviation to the right, 2 standard deviations to the right. Now it's just a z-score of 1, a z-score of 2. That's it. So I hope that kind of makes sense.